So this is an example of a D-Latch, and the idea of a D-Latch is to solve the problem of the invalid input to the RS latch. And the way it does that is, instead of having two inputs, it has one input from power, and that input is fed into a NOT gate, and the NOT of that input is fed into the second gate. So over on this chip, you have two NOR gates. This LED, the one that's not on, is connected to the output of the first NOT gate, and this LED, the one that's on, is connected to the output of the second NOR gate. Sorry, they're both NOR gates. And you can also see that the output of the first NOR gate is connected to the input of the second NOR gate, and the output of the second NOR gate is connected to the input of the first NOR gate. So what's happening is, currently the input is off, as you can see on the app. So the input is off, and what's happening is, this is a NOT gate. So the yellow gate is now a 1. The yellow line now has current in it because you're passing 0 into a NOT gate. And because anytime there's a 1 in the input of the NOR gate, it turns 0. That means that this orange wire now has a 0 in it. So the input to the second NOR gate is both zeros, because there's a 0 from the input and a 0 from the output of the second NOR gate. And this LED turns on because output is 1. And now what happens is, if I turn on the input, you can see that it switches to green, because now the yellow has a 0 and the red is a 1. So this NOR gate over here has an output of a 0. So there's a 0 over here and a 1 from the yellow line, which means that this orange wire now has a 1 in it. So the green LED turns on. And this solves the issue of the invalid input, because it's impossible to have an input of 0, 0 as you're feeding the input into a NOT gate. And you can see that if we call Q and not, if you call the green one Q and the orange one not Q, you can't have them both on or both off at the same time. So your set is when the input is 1, and that's when Q is on, and your reset is when the input is 0 and not Q is on.